So this video is going to continue Chapter 8 of Geometry. It's going to cover from 8.4 to 8.8, and by the end of this video you should know all about tessellations and the different types. So we're going to start with what is a tessellation. So a tessellation is an arrangement of shapes that completely covers a plane without gaps or overlaps. So some examples are triangles. You can have triangles that go on and on forever and cover a plane completely. Or one of the simpler ones is just having squares that go on and on. That's a bad picture, but you get it. So a monohedral tiling, like the two examples I just gave, is a tessellation that only uses one shape. Some examples are the triangle one that I showed you, a honeycomb kind of pattern using hexagons, and then the tiles with the squares. A regular tessellation uses congruent and regular, so congruent regular polygons only, in its that create monohedral tessellations. So for example, that's equilateral triangles, squares, and the regular hexagons. So basically the ones shown here. And then a semi-regular tessellation is the same combination of regular polygons of one or more kind that meet in the same order at each vertex. A demi-regular tessellation is if the arrangement at each vertex in a tessellation of regular polygons is not the same. So for example, if there are two different types of vertices, it's called two uniform, so a two uniform demi-regular tessellation, and if there are three, it's called three uniform, on and on. So now we have a couple conjectures about tessellations. So first, any triangle will create a monohedral tessellation. So you can have right triangles that create a monohedral tessellation. You can have weird triangles, and they'll still create somehow a monohedral tessellation. And any quadrilateral will also create a monohedral tessellation. This is a little easier to show. For example, parallelograms can go on forever. Obviously squares can go on forever. Same with rectangles. Basically, think of these quadrilateral tessellations as bricks or roof tiles. So now we're going to kind of talk about the combination of isometry and tessellations. So here's an example of a tessellation using only translations. So it's the same shape, this little horse, this Pegasus figure, that is just moved from place to place. So you can see it's just repeated, and if these weren't colored, then it would be just exactly the same over and over. And then another example of this is tessellations that use rotations only. So you can see this is the same lizard right here. That's just, well, this is a point of rotation. It's just been rotated here, here, here. And then it's the same with the green lizards. They meet a different point, and they're just rotated again around. And then, so these use a combination of different isometry. So a glide reflection, as we know, is the combination of a translation and a reflection. So it's essentially a mirror image that is moved. So as we can see, there are these mirror images of geese. Here's an original geese, and then here's a blue image of it. But if we would just have taken the mirror image, it would be somewhere over here. a goose, but we moved it, so that's why it's a glide reflection.